So when it comes to aging, what's going on in the body? So we have these hallmarks of aging known as molecular mechanisms. So there's DNA damage, genomic instability. That is something that we've known for a long time. That's the area that I started in over 20 years ago. I was looking at DNA damage, down the microscope. You can clearly see it when there's chromosome breaks, when we get what's called micronuclei. But there's also telomere dysfunction. Elizabeth Blackburn's done amazing work in that, Nobel Prize for that work. Epigenetic alterations, so this is fascinating, the epigenetics. So I'm not sure if has anyone done their biological age? Does anyone know their biological age? No, so you can now look at epigenetic changes, patterns on your DNA, and get an assessment of your biological age. So what we know is there's something called epigenetic drift. So once upon a time, believe it or not, when I first started learning this at an undergraduate level almost 30 years ago, and even 20 years ago when I had the lab, we thought epigenetics was relatively fixed. These methyl groups sitting on the DNA were very robust, that they didn't change. We now know that is not the case. You're exposed to stress in that moment, there'll be epigenetic changes, chemicals and toxins, BPA. The reason BPA is not in your plastic, I'm also someone that goes on tangents like the other speaker, but I'm going to finish the story and get on. But plastic, not to say anything against, this here, no doubt this would be a better form of plastic, but a lot of the older, softer plastics, they have chemicals in them that actually are hypomethylators. They rip the methyl groups off the DNA, they change gene expression, and this is linked to developmental defects in babies, but also cancers. So we now know that epigenetics is very much influenced by our diet and our lifestyle, exposures to chemicals and toxins. So we're learning all of these things, but really what's coming to the forefront is the mitochondria.